Hello and welcome to the session. Let us discuss the following question. It says, a manufacturer produces two types of steel trunks. He has two machines, A and B. The first type of trunk requires 3 hours on machine A and 3 hours on machine B. The second type of trunk requires 3 hours on machine A and 2 hours on machine B. Machine A and B are run daily for 18 hours and 15 hours respectively. There is a profit of rupees 30 on the first type of trunk and rupees 25 on the second type of trunk. How many trunks of each type should be produced and sold to make the maximum profit? So let us now move on to the solution. We have to find the number of steel trunks that should be produced to make the maximum profit. So let X be the first type of steel trunks and Y be the second type of trunks are produced to make maximum profit. Therefore, the total profit on both type of steel trunk, let this be Z. Now we are given that there is a profit of rupees 30 on first type of trunk and there is a profit of rupees 25 on the second type of steel trunk. So the total profit is 30x plus 25y. Now we are given that machine A runs for 18 hours daily and we are given that type 1 trunk requires 3 hours on machine A and type 2 trunk requires 3 hours on machine A, and the maximum time for which machine A can run is 18 hours. So the first constraint (3x plus 3y) is less than equal to 18, as we are given that first type of steel trunk requires 3 hours on machine A and second type of steel trunk requires 3 hours on machine A. Similarly, we are given that first type of steel trunk requires 3 hours on machine B and second type of steel trunk requires 2 hours on machine B and the maximum time for which machine B can run is 15 hours. So the second constraint is 3x plus 2y is less than equal to 15. Now we have to maximize Z equal to 30x plus 25y subject to the constraints 3x plus 3y less than equal to 18, or this can be written as x plus y less than equal to 6, and the second constraint is 3x plus 2y less than equal to 15, and also x and y greater than equal to 0. Now we'll draw the lines corresponding to the equation of the constraint. So the equation of line will be x plus y is equal to 6, and the second one will be 3x plus 2y is equal to 15. Let's now draw the lines corresponding to these two equations. So these are the lines, x plus y is equal to 6, and this is the line 3x plus 2y is equal to 15, and we have to find the feasible region for the constraints x plus y less than equal to 6 and 3x plus 2y less than equal to 15. For that, we'll take any point not lying on the line x plus y is equal to 6, and we'll see whether that point satisfies this inequality or not. If that point satisfies this inequality, we'll shade the region which contains that point, and if that point does not satisfy this inequality, we'll shade the region which does not contain that point. Now if we put x is equal to 0, y is equal to 0 in this inequality, we'll have 0 plus 0 less than equal to 6, which is true. That means 0, 0 satisfies this inequality. So this is the feasible region for the inequality x plus y less than equal to 6. Similarly, we will put x is equal to 0 and y is equal to 0 in the second inequality, and we'll see that this is the region, that is the feasible region for the inequality 3x plus 2y less than equal to 15, and we'll see that this is the common feasible region for both the constraints. Right. Now, we know that by the fundamental extreme point theorem, the optimal solution to a linear programming problem, if it exists, occurs at an extreme point or the corner point of the feasible region. Now the corner points of this feasible region are 0, 0, 0, 6, 3, 3 and 5, 0. Now the vertices of feasible region are 0, 6, 3, 3, 5, 0. Now we'll find z, the value of z at all the vertices of the feasible region, and we'll see that which is maximum. Z is 30x plus 25y. Now we find z when x is equal to 0 and y is equal to 6. That is this point. So z is 30 into 0 plus 25 into 6. So this is equal to 150. Now z when x is 3, y is 3. So z is equal to 30 into 3 plus 25 into 3, that is 90 plus 75, that is 165. Now we find the value of z when x is 5 and y is 0. So the value of z is 30 into 5 plus 25 into 0, and this is equal to 150. And we see that when 3 first type of steel trunks and 3 second type of steel trunks are made, then we get the maximum profit. Hence, 3 first type of steel trunks and 3 second type of steel trunks should be made to gain the maximum profit, and the maximum profit is rupees 165. So this completes the question and the session. Bye for now. Take care. Have a good day.